So you've opened up the Osmosis Gizmo and you should have a screen that looks like this. You're going to start with the Gizmo warm-up. Underneath the words Gizmo warm-up, it says a cell membrane is a thin skin that surrounds a cell. It is semi-permeable membrane, which means some particles can pass through the membrane easily while others cannot. The Osmosis Gizmo portrays a cell, the red square. I think it looks pink, not red, but they say it's red, in a solution of purple solute particles dissolved in the green solvent particles. Press play and observe. So solute is things like sugar. Solvent is things like water. So we have two questions that we're going to answer once we hit play, which is which particles can pass through the membrane and which particles cannot pass through the membrane. So I'm going to go ahead and hit play and we're going to watch. And you're going to try to figure out which particles can pass through the membrane. So which particles, the green solvent or the blue or purple, solute, which one appears to be bouncing off the cell membrane and which appears to be passing through, like that square does not exist. So question number 3 says hit reset and hit play again. What do you notice about the size of the cell? Remember that this pink or red square is our cell, so I'm going to hit play again. And what's happening to that square? I'm going to repeat the process again. I'm going to hit play. What's happening to the size of that square? Is it getting bigger, smaller, or did it stay the same the whole time? All right, we've moved on to the activity observing osmosis. So it tells us to hit reset and set the initial cell volume to 40. You can do that one of two ways. You can type in the number like I just did, or you can slide that bar. Okay, using the solute outside slider to change the concentration. So we're going to fool around with the solute outside bar, and we're going to figure out what makes the cell get bigger, what makes the cell get smaller. So I'm going to put it to the smallest number, solute outside, and hit play. I'm going to watch what happens to our cell. So once again, I have a solute outside at 1, cell volume at 40. I'm going to hit play. We're going to do the opposite now. I'm going to put the solute to the other extreme, and I'm going to hit play, and we're going to see what happens to the cell then. Okay, once again, what happens to the cell? How does it change in size? So which of these situations, having a lot of solute outside or a little bit of solute outside, cause the cell to get larger? Which situation, a lot of solute on the outside or a little bit of solute on the outside, caused the cell to get smaller? All right. So now we get to do a little bit of math, but it's going to totally be okay. We're going to hit that reset button again. We're going to set the solute outside to 10, and we're going to check that the initial volume is 40. So how many solute particles are found inside the cell? So I'm going to look over here, and I'm going to look at how many solutes are inside the cell, and I have a number of 5. And how many solute particles are found outside the cell? So I'm going to look over here for that number. C asks me to find how many solvent. Remember, that's the green dots. Do not count them. It's right here on the table on the right-hand side. How many solvent particles are found inside the cell? And how many are found outside the cell? So we're going to hit play. We're going to let it run for a little bit. All right, and we're going to check to see how stuff has changed. Compared to the number you wrote down before, what has happened to the number of solute particles inside the cell? Has it increased, decreased, or stayed the same? What has happened to the number of solvents outside the cell? Increased, decreased, or stayed the same? Now we're going to do the same thing, solvent inside, solvent outside, and we have our solute concentration. Okay, what has happened here? If you're not quite sure, we can hit it again. I'll let it run for a little bit. Okay, how has those numbers changed? Okay, and then we're going to wait until these numbers aren't changing much, which we seem to be about right there. Okay, what do you notice about the solute concentration outside and inside? All right, so we've made it to question number 4. I'm going to run a little experiment here. We're going to hit that reset button again. We are going to check that the solute outside is 10. The initial volume is 40. We're going to calculate the solvent concentration. To do that, we're going to take the number of solvents divided by the total number of particles times 100. So we're going to look at first inside the cell, what's the solvent concentration? So I'm going to do 89 divided by 94 times 100. Then I'm going to do the solvent concentration outside the cell, 97 divided by 107 times 100. And based on these calculations, for C, you're going to say which one of these is higher, the inside the cell or outside the cell. We're going to go ahead and hit play. And it asks us, did most of the solvent particles move into the cell or move out of the cell? And the hint it gives us is, did the cell expand or shrink? If it shrunk, that means solvent moved out of the cell, and if it got bigger, that means the solvent moved into the cell. We are going to reset. We're going to slide that solute bar all the way over to 1, and we're going to once again do our math. We're going to figure out the solvent concentration. So I'm going to do inside the cell first, 82 divided by 87 times 100. Solvent concentration outside the cell, 104 divided by 105 times 100. And then which one of these is higher? So D asks you to make a prediction. Okay? Do you think the cell is going to get smaller or larger? Once again, I'm going to hit play and let it run. And for E, you're going to confirm your prediction. Were you correct? What actually happened to the cell? All right? So this is our gizmo on osmosis. You have one more question to answer, number 7, where it asks you to summarize the information that we've talked about today. But hopefully this answers any questions you have about the gizmo and has helped you complete the worksheet. If you have any more questions, please just reach out via Parent Square or email, and I'll be happy to help you. Thank you.